Now we'll discuss basic gates. Simply, we have already discussed the basic gates is classified into three types. Simply, those are, the first one is a NOT gate, the second one is AND gate, the third one is OR gate. These are the three types of basic gates. Now we will discuss in detail regarding these three basic gates. First, I am going for NOT gate. NOT gate. Simply, the first point, the logic operation of this NOT gate is to inverse the applied input. This is the purpose of this NOT gate. The logic operation of NOT gate is it will inverse the applied input. That means whatever the input is applied, that input is simply inversed. First thing, we have already discussed this logic gate consisting of two inputs. One is 0 or 1. Those are the two inputs we have already seen. When we applied 0 to this NOT gate, then output will be 1. It will be inverse. When we apply 1 to this NOT gate, output will be 0. Output will be 0. That means 1 is changed to 0 and 0 is changed to 1. This is the main purpose of this NOT gate. That means inverse the applied input. When we seen in mathematical expression point of view, let us consider A is the applied input. A is the applied input and Y is the output. Y is the output. A is the applied input, Y is the output. Now we can write the expression, mathematical expression for this NOT gate is Y equal to A bar or A complement. We can write like this, Y equal to A bar or A complement. Y equal to A bar or A complement. Here A is the input, A bar is the output or A complement is the output and Y is the output. Simply we can represent like this. And the symbolic representation of this NOT gate is like this. It is the symbolic representation. Symbol of NOT gate is like this. Here it is A is applied here and output is Y equal to A bar. It is the symbolic representation. And truth table. While coming to the truth table of this NOR gate is, first we have to represent inputs and then outputs. While designing any truth table, first we have to represent inputs and then outputs. Here in this case, only one input are there. One input is there. That is A. A is the input and output is 1. Y is the output. So now A is the input. For A, we have only two possibilities. A either may be a 0 or it may be a 1. Either may be a 0 or it may be a 1. When A equal to 0, then output will become 1. Inverse. A equal to 1, output will become 0. Inverse. Like this. This is the functionality of NOT gate. Now The second one is AND gate. First gate, NOT gate is already discussed. The second gate is AND gate. Simply, this AND gate performs the logic operation of multiplication of two applied inputs. Simply, the purpose of this AND gate is it will perform the logic operation of multiplication of two applied inputs. Let us consider we need two inputs. So A comma B, I am assuming A comma B are the inputs. Let us consider A comma B are inputs and Y is output. A comma B are the inputs, Y is output. We have already discussed this AND gate performs multiplication of two inputs. So here it is output Y, input A, B. Simply this AND gate performs the multiplication of these two inputs A into B. So output will become Y is equal to A into B. It is the mathematical expression for AND gate. And symbolic representation. Is, that means the AND gate can be symbolically represented as like this. This is the representation of AND gate. These two are the inputs and it is the output. So inputs we have already discussed. Inputs are A and B. So here is A, here is B. Output is Y. So Y. Expression is Y equal to A into B. It is the symbolic representation of AND gate. While coming to the truth table. Truth table. Now we have already discussed this gate performs multiplication of two inputs. So first I am writing inputs and then outputs. So how many inputs are here? There are two inputs. So A, B are the inputs. How many outputs? Only one output, that is Y. Y is the output. So here two inputs. So possible combinations are four possible combinations. Those are 0, 0, 0, 1, 1, 0, 1, 1. Those are the four possible combinations. 0, 0, 0, 1, 1, 0, 1, 1. And output. Simply AND gate performs multiplication of two inputs. So the multiplication means here 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. It is the truth table for AND gate. It is the truth table for AND gate. Now the next gate is OR gate. Next basic gate is OR gate. Simply, OR gate performs the logic operation of addition of two applied inputs. Here, OR gate AND gate performs multiplication of two applied inputs. OR gate performs addition of two applied inputs. Addition of two applied inputs. Here also we need two inputs. So let us consider A comma B are inputs. We need two inputs now. So consider A comma B are the inputs and Y is output. Now the basic operation of this OR gate is addition. So the mathematical expression of OR gate is simply it is addition. Na? Here the inputs are A and B. Just simply we have to add Y equal to A plus B. It is the mathematical expression. And while coming to the symbolic representation, is it will be represented like this. Just look at here. Here it is a straight line and here it is a somewhat curved line. Inputs are A and B. Output is Y equal to A plus B. Now coming to the truth table. For OR gate is here again inputs and outputs. Inputs are AB and output is Y. Here two inputs. So we have four possible combinations: 0 0, 0 1, 1 0, 1 1. Now Y is the output. Y is obtained when we add A plus B, A and B. So 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. Like this, we are having the truth table for OR gate. This is regarding to basic gates only.